somewhat ironically, so the title of the talk is, accelerometers, how do they work? I have no clue how accelerometers fucking work. I know nothing about electronic engineering, or the physics of it. I don't actually even know, I'm not proud of this by the way, I don't even know where the accelerometer is in this thing. I guess what I do know though about is using these things to design kind of successful games that are fun, games that make sense to the players and so forth. So I guess what I actually should have called the talk was accelerometers, how do we make them work for us? And it was like slightly less of a sexy title. So I apologize if you came here to learn about the electronics of accelerometers. You should probably walk out of the room now. But beyond just accelerometers, so the subject matter of this talk is somewhat specific, but I think it's also relevant to a lot of relevant more broadly. So whether you're working with other devices like Kinect or touch screens or whatever weird future device or game controller comes out, I think a lot of the lessons I'm going to talk about today, both technological and design, apply. So it's a specific topic that's supposed to have more broad resonances. Okay, so here's a Move controller, which has, like I said, both an accelerometer and a gyroscope in it. 3D space, there's three-dimensional vector of acceleration. But the problem is, and this is why accelerometers suck and are really difficult to work with, that there's also gravity, right? And so gravity is this constant vector that is applying acceleration kind of downwards. But the accelerometer has its own frame of reference, is kind of the technical term for it. What this means is you kind of have this noise, this value. So let's say the value of gravity is 1. That this kind of value of 1 is always pointing downwards, but it's going to show up on different axes in your accelerometer data, right? So if I'm holding the controller like this, versus holding the controller like this, versus holding the controller like this, that acceleration data is showing up on these different axes. The accelerometer at a bunch of points in this window of time, and I take kind of the differences between these points, between this acceleration and what the acceleration was the last sample I took. And what you start getting, if you look at this what the acceleration was over the course of this 250 milliseconds, is kind of like a rough view of it's like some rough approximation of jitteriness. And so I can look at how I'm never interested in an acceleration value in and of itself. I'm interested in the acceleration value compared to other acceleration values over that window. And if that kind of jitteriness gets too high over some magical threshold that I've tuned very carefully over years, then you're dead, you're out, your light goes out. If you're like a scrappy indie like me, and you have limited time, limited resources, and maybe you're not the biggest hotshot computer scientist or mathematician in the world, it's really difficult fighting that battle, that gesture recognition battle, or those neural networks that are trying to classify data. And so to me, these days, it's always a red flag for me, am I fighting this uphill battle I can't fight? So instead, in Joust, bringing the whole idea of the game back to this simplest atom of the technology, or in the case of the Scipio cubes, constraining this device spatially or in some other ways that suddenly make it easier for me to think about and design around the technology. And finally, I was thinking about this the other day. It took me years, literally years, of messing around and tinkering with these physical games before I really kind of got the depth of it and got good at it. And I think that's part of the reason why there's so much bad Wii shovelware out there, right? Or so many bad Kinect games, because it's really difficult thinking about physical games. I almost see them as a different medium altogether than traditional video games. It requires a whole different way of thinking and unlearning all this stuff that you thought you knew about video games. Most of you in the audience are probably cleverer than me and could pick this up faster, but it really did take me, all those failed projects and other semi-failed projects and some more successful ones, and to the point where I finally, at some sort of deep level, got
understood what this whole physical gaming, motion control gaming thing was all